Awesome. So before the break, we got through the Python list methods that are typically important. So like sorting, sort, reduce, filter, and map. Now we're going to talk about quickly. I'm going to show you how you can zip two lists into a dictionary. So that could also be that could also come in handy. Okay. So now we're going to talk about function zip. So let's say I have these two lists. So we have a list of 3 numbers, a list of 3 letters, and I can create a zipped version of this that pretty much takes the two like a zipper. So zippers have teeth, and it takes 2 teeth and kind of like puts one into the other. So we have a zip function that will just take 2 lists pretty much. So I can give it numbers and I can give it letters. And let's see what it prints out. Okay. And I'm just gonna run the file. Should have probably here. Let me move this stuff into a file so we don't. Okay. There we go. So, oops, that's not what I wanted to do. I wanted to clear. So when I ran it, it gave me a zip object. So let's try putting it into a list and see what happens, because I gave it 2 lists. So maybe that's the closest thing that it will give me. So if we look at it and we transform it into a list, it basically gives me a list of tuples, and each tuple is each element from the 2 lists. Let's see what happens if we actually remove one of these. Will it give me an error? It will only zip the one that it finds an equivalent to. So you'll always end up with coupled objects pretty much if you give it 2 lists. So if I wanted to turn this into a dictionary instead of a list, I can just do this. I can cast it as a dictionary, and now it's a dictionary. It takes the first element as the key and the second element as the value. Nothing too fancy here, just a function takes 2 lists and matches up each element with an equivalent element from the second list. Questions on this?
Yes. Is the 3, so when you took out the C, is the 3 hidden, or is it completely removed? So if you called on it later on,
It
there's
completely,
like,
yeah, it didn't make it to this new list. Yeah, so it only basically creates a new list out of the 2 existing ones. So the 3 existed still in numbers, but inside of this zipped object or list or dictionary, whatever it is, it's a zip object. So inside of that object, only the ones that had an equivalent one, like at the same index, basically, ended up in here. So yeah, if I had removed the C again, actually, well, you can see it here. So when I remove the C inside of zipped, these are the only elements that I see. But when I add it back, I see that it was added here.
okay, thank you.
Any other questions? All right. So let's move on to another type of thing. Try accept. Okay. So when you're building your application, sometimes you have code that will cause an error and you don't really know, like it doesn't behave the way that you expect it to, and it throws an error. So we can use something called a try except block to write code that we know might throw an error, and we can have basically like an alternative for it. So if we know, let me just start writing code actually. So anything within a try block will execute until it causes an error. So let's say I have a few definitions here, a few variables. Okay, so I have these three variables, and let's say I want to say D equals A plus C. So we've seen before that if you try to add an integer to a string, it's going to give an error. So this code will probably give us an error. Print E. Let's actually do another example ahead before it. Just add A plus B. So A plus B shouldn't give us any issues. And then if we try to print out, okay. If I print this out, it should still print out. When it gets to this line, it will probably break. So I will not get anything here. So you see there's still a red squiggly. It's not liking that you only have a try up here. Always coupled with a try is an except. So basically it's going to try running this code, but if an error happens, it will go into this except block. And this except block will just print like, oh no, there was an error. Okay, let's try doing that. Clear this. Try accept. Okay, so got through here. It printed out 3 because it added 1 and 2. And then it got to this line. This line caused an error. And so it jumped over whatever else is in here. So even if I had a bunch of code in here, it just skips it. And then it goes into this except block. And if we wanted to, we can also add an else. This else will handle success. So after this was successful, if we wanted to say like this operation is done or something like that. So I can say success, no errors. Let's say I comment this one out, or I'd say B equals 5 or 6. And then I try to print this out. So it prints out these two. It then goes to this else saying that there was success. It did not have to go into the except. One more part of this that sometimes you might see is a finally. So finally is going to execute regardless of whether you get an error or a success. So if we print out, we can just print here. I don't know. This happened regardless. And if I print it out, so there was no errors, and then the finally goes through. If I put back the error in here, oh no, there was an error, but this happens regardless. Any questions?
This just has to be in order. Can you be like try, else, and except, or it has to be like in this order?
Let's try it. No, it does not like it. You have to always have try and accept. So you can have try and accept without anything else, like without else or finally. But if you're using try, you always have to put accept.
Sweet.
Other
Thank you.
questions? Of course. Other questions? So let's see. I won't go into too many details, but let's see. So you can grab the exception. So if I say accept, and it will grab whatever exception was going to happen. So it's not going to be like a silent error. It's going to actually give you the exception. So I can print it out here. So print E. So it will tell you the same error that happens if I didn't have this try except. Like, let me test this out real quick. So if I try to do G equals 4 plus D, and then I try running it, it'll give me this error. So the type of this error is a type error. If you were trying to, let's say, divide by 0, there's like a divide by 0 error. So like 4 divided by 0. I try to do this, 0 division error. So each type of exception, so these are all called exceptions. Each type of exception has a certain type. So this one is 0 division type. This is a type error, and so on. So if you don't really know which error you're going to get specifically, you can handle it as like just grab it as exception in general. So now if I run this, unsupported operand, so it printed out this, right? This is, let's see, where is it? It prints out the value here of this exception. Let me see if there's anything inside of E. I'm not sure if you can get the type. It might be type, like just printing type of E. Might just work. Let's see that. I'm going to comment this one out because it's a little distracting. Yeah, so the type of it was type error, and it still goes on and prints like, oh no, there was an error. If you wanted to get the actual like built-in error that happens, you can just, like we did earlier, print out E, and that will help you understand what is happening. What else? What else can I say about this? If you want, you can have multiple accepts. So let's say you want to handle like a type, what was it? Like a 0 division error. So I can accept a 0 division error as E. So I can grab specifically only 0 division error, and I can say here, there was a, or I can say like, you are trying to divide by 0. And then I can handle whatever else is as just like a generic error if I wanted. So now if I added this, yeah, equals 4 divided by 0. So it causes an error here. It then jumps into the 0 division error because that is the type of error that happened. And I am specifically expecting that error. So I can have like a more customized print statement if I wanted to. So I could print this, and I can also print afterwards E. I can print whatever that error wants me to know. So division by 0. But if I copy this out, so this is just the type error that we had before. If I print this, so it's going to skip this because it's not a 0 division error, and it's just going to go to the generic exception one, and it's going to print out. It prints out the type, which we were printing out here, prints out the string of the error, and then it prints out my specific error statement that I wanted to print out. I could also just add type error here. And you have a type error. So now if I run this again, where it was going into the exception block here, it's actually going to go into you have a type error over here. Questions on this? No. Yeah, you don't have to really know all the exception types in the beginning. This is just for you to know that you can actually do this if you'd like to. Yeah. Any questions, comments, concerns? And try accept. All right, well, this was try accept. You can just use it for error handling inside of your code. That way, so basically, if you don't have these accepts, your entire program will completely shut out. So if I had at the bottom of this, I had like 4x in range 10. I just want to print out x. So here, you see, even though I got the exception, there was an error, I was still able to continue on with the rest of my program. However, if I did not have any of this, if I did not have the try except block, and I introduced an error up here, then I'm just going to get the division error and my entire program is going to exit out. So that is the benefit of having these try except blocks. It's so your program basically doesn't break. You can handle it more elegantly. Awesome. Any questions on that?
Yeah, is that usually in a separate file?
These ones, no.
Okay, you just put it in the file with the program.
Yeah, exactly. So this is just like while you're writing your program, if you have something that you expect, like maybe it's based on user input and you want to make sure that the user input, it doesn't cause any errors. You can do a try except block just to catch any errors that are coming in. Or if you're trying to do like an API request, which we'll talk about APIs way later, but yeah, stuff like that you want to put within your code all along. I just put it in a separate folder right now, files, so I can have the examples separate.
When making like a full application, would you recommend having like an accept.py file somewhere, just kind of importing it into any kind of heavy load like main files that are being used, or would you just kind of like copy and paste this all over?
It depends on what your exceptions are. So typically with like, let's say if this code is going to just add numbers and I expect it to only add numbers, maybe the only thing that I'm checking on is a type error or just a regular exception. So you don't really need to have like all the different possibilities. I don't know how be like having it in a separate file and importing it would look, I mean, you can put it in a function, you can just say like, try this, and that function would then try, and then the exceptions would handle themselves. But I think just having this basic exception block that handles any exception regardless of the type of it, and just prints out your exception and then moves on with your program. I think that's the minimum that you would need. So I guess long answer short, basically depends on how your files are structured and how many exception stuff you need. And if you need it in multiple places in your code, then you should probably put it in a function and then use it in different places in your code, like that way. But if you're only using it in one place, I would say it's fine, because if it's in one place and it has to live somewhere, having it live like in your same file would be fine. But yeah, awesome. Any other questions? Alrighty. Okay. Today's a lot of information. Okay, I'm gonna start a new file because we're gonna talk about something different. Let's say modules. Okay, let me remember to open this. Okay. So you guys have probably heard of these words like module, package, library, framework, tossed around a lot. Basically, all of these words mean that they are code that someone else wrote that you can use and make your life easier. So it's nothing too super special. It's just like a collection of files that have code in them that you can use throughout your program yourself. So an example of that we saw earlier with like the func tools. This func tools. So I went to the imports up here, I hit command and I clicked on it. If you're on Windows, you can do control and click on it. You will actually go to the file that someone wrote. So an actual person has written this and you can see their code. And all of these functions are pretty much open to you. So like compare to key, that's a function. Reduce, that's the function that we used. And it takes in a function and a sequence. That's what we were working on earlier. Okay, well, yeah, I'll look at this later. I'm interested. But yeah, all of these are basically just pieces of code someone else wrote. So typically when you're writing your applications, you will be writing your own Python files. So having everything in one file becomes very hard to read, hard to understand. So you typically want to try to put things in the categories that they belong to. So there's a bunch of people who have opinions on where you should put things. It eventually becomes it becomes what is the easiest to use and what is the easiest for someone else to use. So let me give you an example. Here I created this modules.py. This, I just want to show you how I can import modules that I've created. So I'm going to create file.py, and this will contain two functions. So let's say these are two functions that I'm going to use over and over in my code. And yeah, there we go. So just a say hello function that prints hello, hi there, and then and say goodbye function. So in here, if I want to import this, there's a few ways of importing. So I could say import file one. So you don't really need to say .py. Python automatically recognizes a Python file as something called a module. So if you import it like this file one is, you can kind of treat it as like a variable that you can use the dot notation to access whatever's inside. So file has these two functions. So now if I want to use them, I could say file one dot say goodbye or say hello, because we're starting. Say hello, and then to call a function, you have to put the parentheses, and then if I run this, there we go. It just says, hey there. If I wanted to, I could also import this file as a different name. So as greetings. And now I can use greetings as the name that I use throughout the program to access whatever is inside. So if I run it again, it still works because I changed it, both of these to greetings. Let's say I have this file one that contains a lot of functions. And in this modules file, I know that I only need one. I only want this say goodbye function. So to do that, you would specify where you're getting your what you want to import from. So I'm going to say it's from file one. Oops, file one. And then I'm going to say import say goodbye. And then now I can just say, I can just use this function as it is, say goodbye. And it works. Let me see. You can also import multiple. So you can just put a comma here and then import all the ones that you want. A benefit of this is a lot of these libraries or a lot of these modules have a lot of functions that you might not use all of them. So if you import it all, sometimes let me see. You can do this. So you can do from file one import star, and this imports everything. So you will automatically have access to all of these functions without specifying that it's coming from, without specifying the file name. It basically takes these definitions and puts it into the scope of this file. But if you do this with a very large library, you're basically wasting a lot of space, wasting a lot of memory in your program. So this is not really recommended unless you know exactly what you're importing. So like right now, I'm only importing these two functions and I know that there's only two and it's not bad and I'm only going to use these two. So I can do this. So there's a bunch of ways to import things and you can just kind of use your best judgment.
What was the difference between line like 1 and 3? I kind of don't get that part. Import field as this and from file import this. Like what is?
Yeah, so when you do an import like this, so import file one, it basically gives you access to a variable called file one that you can use to access what's inside of it. So to access these functions here, I would have to say file one dot say hello. Here, this one, you're actually importing the functions themselves by name. So you don't have to actually call file one dot something. You would just do say hello because you imported it here. This line and this line are equivalent only because these are the only two functions in here. So if there was a third one here, say something. Oops. Let's just print something. So in this case, this one is importing everything. It's importing all three of those functions, and this one is only importing these two that you've specified. So if I didn't
Thank
want to, yeah. Awesome. And then when I put the as greetings here, this is just giving it an alias. It's giving it a name that you can use throughout your program, which would be equivalent to using file. Any other questions?
Do the files have to be in the same directory or can they be in different directories?
Yeah, so that's where it gets a little tricky. So with imports, if you do, see, I think dot main, no, dot slash, I need to remember.
It might not be, you misspelled import.
Oh, thank you. I spelled it even worse the second time. Okay. Import dot. So everything, but if you don't put a dot, that's just expecting what's in here. So dot is your current directory. Dot would be one level up. So dot was curriculum. So dot one. I actually need to do some more research into the whole
I think it would
folder.
be dot slash to go into that week one.
It was, yeah, but it has to be inside of a string, right?
Yeah, I think so.
Yeah.
Because you had it working a second ago.
Yeah, let me try. I think you would have to say from this. So let's say I want to pull one of the files from yesterday. From this, import main. Let's see if that works. I don't think that works. I think I would have to specify, oops. Yeah, I need to look into this one more time. I honestly forgot the syntax for this. But basically with the imports, you can import from folder that you're in, but you can also do it from the other ones. I'm just blanking on how to do that at the moment. I thought it was this way. Import main. Yeah, we'll have to. I'll get back to you guys on this. Yeah.
There's a question in the chat.
Oh. Do modules daisy chain? So file 0 as functions, files 1, imports file 1. I don't think so. Let's try that. So let me create another file here. File 2.py. Let's say this file. I'll do from file 1. Import star, just because I want to import everything in here. So if I say here, instead of importing these and this, comment the entire thing out. So I can import file 2. Oh, it does. Yeah. So file 2, because I imported everything, it has the context of these functions. So I'm actually able to use this. So if I say goodbye, it should print out. Yeah. Awesome.
If you don't import it like that with the star though, if you import it the other way, would you have to do like file 1 dot file 2 dot say whatever?
Let's try.
Would you have to chain those?
Import file 1. Then we go here, import file 2. And then here it would be file 2 dot file, yeah, dot file 1 dot say goodbye.
Gotcha. Okay.
Oops, great question. I never thought of that. Yeah.
I just feel like you're probably not going to import with a star a lot. A lot
Yes.
of those libraries are huge.
Yes, 100%. Like the math library that you guys mentioned and stuff like that. Those are, yeah, they're pretty big. Awesome. But yeah, so modules are basically just any Python file with, or any file with a .py at the end of it. So let me see if I had this one in here. So this one is one level up. So I don't know how to deal with the folders, but if you want to import this zip, which is on the same level as the folder that we're in, I can do .zip. Or not. Okay, never mind. Yeah, we'll get the proper way to import something from another file, or another folder in a bit. Any more questions on this?
Can you just go to file 1 and file 2 again real quick?
Mhm.
Okay, and then file 2, how it's pulled in there, and oh, it's the whole thing. Okay,
Yeah.
thanks.
Import system. Yeah, so that one we'll have to do like a certain. I see. So Jody, you just posted this. Let me see here. Yeah, we were gonna talk about paths to files and stuff like that. So let's say Python insert. Path to folder. Okay. Yeah, I think you can specify the path and then you can import it then, because when you're running a Python file, it will only know kind of within the context of what's around it. So you might need to change where the path is. Which is a great segue to what we were gonna say, what we were gonna talk about next. So let's see. I'm gonna add this folder, just not this one. This one, what else was used? I think it's just these three. So it's a little more organized. Okay. So for our last topics, basically, we're just going to talk about a little bit about file paths and being able to like read and write to a file, because that will definitely be something that you will see in Python. Let's open a new file. Files read, right. All right. So even though we didn't figure out the import yet, we can talk about regular file paths. So every file that we have on our system has two things that we care about when we're trying to access it. We have the file name, so this is the name that's actually here, and then we have the path to that file. So if you see here, I hovered, you can see where the path is. So that's like the one with all the slashes that gets to the file itself. So you see here, I have the squiggly, which means home, /desktop, /code platoon, /tango, and so on. So that shows you how to get to that file from the home of the computer. from the base, like the root of the computer. File names often have this extension. So everything after the dot is called an extension, and it only tells you what type of file this is. So py is a Python file, txt is text, like docx is like a Word document, PDF is a PDF and stuff like that. So the importance of that is just to know how to read it, how to parse it. We're not really going to talk about fancy file types right now. We're just going to talk about the txt files. But before we get into accessing this file, something worth mentioning is these paths will look different depending on which operating system you're on. So if you are running on a Windows machine, your paths are going to have the slashes like this, versus if you're running on a Unix type machine, so Linux, Mac, stuff like that, your slashes are going to be like this. So let me give you these examples. So this is basically what these what you would see on each machine for the same type of oh, this is a txt. Oops, I'm like, why isn't it commenting out? Okay, here we go. So because of this difference, it's very important when you're writing your code to have it be system agnostic. So basically, if you run it on any machine, it should still work. So if let's say you guys are writing your assignment and you have, you put the path to one of the files that you need dependent on your user. So and let's say you're on a Windows machine. So it would be like C/user/your name /desktop, whatever, until it gets to the file name that I need, right? But then I try to run it on my computer and it doesn't work because this path is specified to your computer. Not only does it have the wrong slashes, but it also has a path that only exists on your machine, but doesn't exist on mine. So that causes a lot of issues. Especially when you're writing code for like a company and you're sharing code between different people's computers. So there is one library that is very useful. It's called OS. So OS allows you to get like what is it called? Functions that help you talk to your operating system. So the same way in the command line, we have these certain commands like cd, ls, stuff like that. This OS library allows you to basically do commands commands like this, pretty much. So if you guys have your computer open or like your editor open, import OS, and then you can do get CWD. So this stands for get current working directory. That means this will give you the directory of the Python file that is currently running, which is something important to note. So if I'm going to run this, am I in the right thing? No, I moved this. I need to move this in here. Okay. Oh, I didn't print it out. Let me do that. Okay, let me clear so it's more visible. Okay, so for me, it printed out this. This is the path on my local computer to this file to the file, to the folder that I'm in, because I'm in files read write .py, and this file is in this folder, so it gives me up until this folder that I'm in. But if you ran it on your computer, it probably looks different. So this is something that is called an absolute path. An absolute path is just a path that begins at the root folder of your computer up until where you are. A relative path, so I'm gonna, this is the wrong way to comment. So this is a absolute path. A relative path is a path that is relative to the directory that you're in. So it's relative to the file that is running this code. So if I said that I have this example.txt file, right? If I wanted to access this file, I would start with the /, and that would have, so if I just put it in quotes, the /, then I have the context of the folder that I'm in. So example.txt. This is something that's called a relative path. Oops. If I wanted to get the absolute path of this file that I have, I can do this. So with this OS library, let me print. I can say os.path absolute path, and then I can give it the name of the file, example.txt, and I believe it should print out. There we go. So the second one, it printed out the path to this folder, this file right here. I wonder if it'll work for something else. So if I said loops and conditionals.py. So this one assumed that this file here is within here, because I just told it to pretty much append the absolute path. So it takes the current working, like the path until the current working directory, and then it adds this file to it, which is probably not what we want to do. So if we want to look for it, we can start doing .. And then this is the file. Let's see what happens now. Okay, so now it knows the correct context. So absolute path just takes the current working directory and then it appends the correct path to it, unless if it doesn't find it. So earlier, loops and conditionals is not a full file within my directory here. So it just gave me a path that has it, but it wasn't correct because it doesn't exist there. But now since I gave it a correct relative path, right, it actually gave me the correct one. So it put the week 1, day 3 instead of day 4. Questions on this? I know it's a lot with the path stuff, but the important thing to understand is that there is a relative path and then there is an absolute path. An absolute path starts at the root of your computer all the way until where you are in your folder. Relative path starts at your current folder and then it goes outwards. So dot is your current folder. Dot is the folder above, and so on. So yeah, when you're trying to find files and when you're trying to access files, keep those into consideration, pretty much. So if you want something that will build a path for you, based on whatever operating system this code is running, you would probably want to use something like this instead of just having the dot slashes, because if you're on a different type of machine, the slashes might not work. Because in Windows, I would have to put the slash like this. Any questions? No. All right, we're almost done. Last thing I want to show you is just how to actually read and write from a file. So here I have an example.txt. Let me just put some text. So something else, something, I don't know. Okay. So this file is just around here. There is a function called open, which allows you to open files. So you'd have to give it the file name or the path. So if you just give it the name, it's going to look inside of your current directory. If you give it the path, it'll go specifically to that path. So right now I have this file in here, so I can just give it example.txt. And I will just call this my file. The file equals open. And this function, if you just give it a file name, it will open a file with read permissions only. So I can do for line in file if I would like. Print line. And let's see. There we go. So it grabbed every single line and then it printed the line. If I wanted to, let me see. Okay, so if we do it this way, if you use just the open and you set it equal to a file, you have to always remember to close the file. Or sorry, file.close. But if you don't want to deal with this, the newer, so now in Python, instead of doing this and this, you can just say, actually, I'm going to keep this example here. With open, so basically you open the file. And then you say as file. So you still have access to that variable. And then you can put whatever code you want in here. And that is it. So whenever it finishes the lines of code, it goes out of scope of this line here. Then it will automatically close the file for you. So you don't have to remember to close it. So if I do this, it prints it again. So something else. Yeah, so opening a file is and reading it is that simple. There is a function file.read. I want to see what that does. Okay, so that one prints everything as it is. If it doesn't loop through each line, it just prints the entire file. But a lot of times you want to go line by line, so it's more helpful. If you don't put anything, like I said, it has read permission automatically. So the second the second parameter in this open function is the mode. There's a few modes, so read obviously is for read. What if we want to write to a file? Well, we can put a W. The W. Wait, let me not mess with this example. And then start a new one. Okay. So I want to write a file. So if you have the read flag and this file does not exist, it will give an error. But if you are trying to write a file and the file does not exist, it will create it for you. So that's just something to keep in mind as well. If you wanted to just create a file, if you want, so you don't care about doing anything, you just want to create the new file, you put an X. So X is for create, R is for read, W is for write. So let's see what this does. So we can do file.write. And we can send something here, and then I can do file.write again. This is something. Okay, so right now our text file looks like this. I am going to run this code. And if I go look at the text file, we see two things that happened. One, it didn't print on different lines. It just prints right after one right after the other. And two, it overwrote what I had. If this ever happens to you and you need the text that was in here, you can do a Control-Z and it'll go back to what it was. But basically, write will overwrite your entire file. There is another flag, however, which is an A. Can anyone guess what the A stands for?
Append.
Exactly. So append is just going to append it to the end of the file. So if I run this instead of this, and I look at my file, we see that it appended it to the end. So we see here, it added it to the, like it added both of those lines to, or both of those phrases to the same line. If you want a new line, you will have to specify that it's a new line, just because of how files are written. Files are written like character by character, pretty much. So if I want a new line here, I will have to add a new line. So if I do this, now it will append that. It appended it to the end because, so if we go back, if there is no new line inside the file, so if there's no empty new line, it will take the end of the last line because that's technically the end of the file. But if you have an empty new line here, it will add everything to that new line and on. That's just a little thing about files. So now, since I added the new line, if I run this again, then we see that they were added afterwards. Yeah, there's also one last thing. If I have a list of lines, I can just say lines, and this is like couple. There is another function called write lines. So file.write lines, and this write lines will take a list of lines pretty much that you need to write. And if I'm not mistaken, that one should automatically add the new line. So let's test it out. If we look at this, it did not. So you do have to specify if you want the new line character. I think this one will take, never mind. I thought it would take like a parameter of what you want to end the line with, but yeah, basically when you're writing to files, just add a new line. And if I run it again, now it was added to the next one. Run it again. There we go. All right. Any questions? Let me check here. Can open file name be a variable? Yes, it can. So you can specify the path to the file above, and then you can put the variable inside of this instead of the string. So as long as it's a string, then it will work.
What was the difference between the file dot write lines and the other ones before that one? I kind of didn't get that.
This one?
Yes.
Yeah.
that one.
So the write lines will take a list of strings versus this one will take a singular string every time.
Oh, okay, thank you.
Yeah, so write will take a string and then write lines will take a list. Other questions? All right, our lesson is done. That was a lot that we got through today, a lot of different types of things. Just want to show you guys some of these resources. So a lot of the array method or the list methods that we talked about have equivalents in JavaScript. So this is just if you're interested to see what JavaScript has. So you see JavaScript has map. Map will definitely see when we're working with React. It has a filter. It has a bunch of the same ones. Another one of these. I should probably open them in new ones. Oh, this is just the same one, but with lambda-like expressions. So basically doing it like this with the fat arrow syntax. Explaining just the difference and or the similarities and stuff like that. Python modules. That does not work anymore. That's good to know. Okay. And then import syntax comparison. This is pretty interesting. So just seeing how different things are imported. Yeah, if anyone finds a good resource on the imports and importing from different files in Python, let me know. Oh, this one. So you can import like this. You can import from, I think I was doing it in the opposite, but I thought this was a JavaScript thing. It is JavaScript. Okay, I'll stop talking. Yeah, post it to Slack if you find any good resources. And yeah, we have a few assignments. This one is the same one, but in Python. I think we did this yesterday, didn't we? The def grandma, yeah. Okay, so ignore this one. But the rest of them.
That's a different def grandma. It has.
Oh, this is debug.
Yeah.
Thank you. Yes, I forgot about that. So this one, it's already written for you. It's in JavaScript, so not Python. So you can leave that one to last. But yeah, basically it's a little broken. Try to fix it. Any last questions before we go to lunch? No. Awesome. Thank you everyone for today. Let me stop the recording.